Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is surface chemistry, advanced emulsions and colloids. This is a high-weightage concept for both NEET and JEE exams, and understanding it in depth will not only help you ace conceptual questions but also master the tricky numerical problems that often appear in the exams. So, let's get started. To begin with, let's first understand the concept of colloids. A colloid is a heterogeneous system where one substance is dispersed in another substance in the form of very small particles. These particles are so tiny that they remain suspended in the medium and do not settle down, unlike in true solutions or suspensions. The dispersed phase is the substance that is present in small amounts, while the dispersion medium is the substance that surrounds the dispersed phase. Colloids exhibit properties that are quite different from those of true solutions and suspensions. One of the most important properties is the Tyndall effect, where a beam of light passing through a colloidal solution is scattered by the colloidal particles, making the path of the light visible. This effect helps distinguish colloidal solutions from true solutions. Colloidal particles also exhibit Brownian motion, which is the continuous zigzag movement of the particles due to collisions with the molecules of the dispersion medium. Depending on the physical state of the dispersed phase and the dispersion medium, colloids can be classified into different types such as salts, gels, emulsions, and foams. But today, we will focus on two major types of colloidal systems, emulsions and colloidal dispersions. Let's now talk about emulsions, a special type of colloid where both the dispersed phase and the dispersion medium are liquids. In an emulsion, tiny droplets of one liquid are dispersed in another liquid, which is immiscible with it. A common example of an emulsion is milk, where tiny droplets of fat are dispersed in water. Another familiar example is butter, which is an emulsion of water in fat. Emulsions can be broadly classified into two types: oil-in-water emulsions and water-in-oil emulsions. In an oil-in-water emulsion, oil droplets are dispersed in water, whereas in a water-in-oil emulsion, water droplets are dispersed in oil. The type of emulsion formed depends on the relative proportions of the two liquids and the nature of the emulsifier used. Emulsifiers play a crucial role in the stability of emulsions. An emulsifier is a substance that stabilizes an emulsion by reducing the surface tension between the two immiscible liquids. It forms a protective layer around the dispersed droplets, preventing them from coalescing and separating out. Common emulsifiers include soap, detergents, and certain proteins. For instance, in mayonnaise, egg yolk acts as an emulsifier to keep oil and vinegar mixed together. Emulsions have wide-ranging applications in our daily lives and industries. In the pharmaceutical industry, emulsions are used in the formulation of creams, ointments, and lotions. In the food industry, emulsions play a vital role in the preparation of products like margarine, salad dressings, and ice cream. Even in the petroleum industry, emulsions are used in drilling fluids to enhance the efficiency of oil extraction. Now that we have explored emulsions, let's move on to colloidal dispersions, which include a wide variety of systems where solid, liquid, or gas particles are dispersed in a medium. One of the most common types of colloidal dispersions is a sol, where solid particles are dispersed in a liquid medium. Depending on whether the dispersion medium is water or an organic solvent, sols can be classified as hydrosols or organosols. A special type of colloidal dispersion is a gel, where the dispersed phase forms a continuous network in the dispersion medium, giving it a semi-solid consistency. A familiar example of a gel is gelatin, which is used in food products, cosmetics, and pharmaceuticals. Gels have the unique ability to retain large amounts of water, making them ideal for applications where moisture retention is important. Another fascinating type of colloidal system is foam, where gas is dispersed in a liquid or solid medium. Examples include shaving cream, whipped cream, and certain types of sponges. Foams are formed by trapping gas bubbles in the dispersion medium, and their stability depends on factors such as the viscosity of the medium and the presence of stabilizers. One of the most remarkable properties of colloids is their ability to exhibit adsorption, where particles of the dispersed phase accumulate on the surface of the dispersion medium. This property is utilized in a variety of applications, such as the purification of water using activated charcoal and the removal of impurities from air using adsorption filters. Colloids also play a critical role in biological systems. For instance, the cytoplasm of cells is a colloidal system that facilitates the transport of nutrients and waste products. Blood is another example of a colloidal system, where red blood cells, white blood cells, and platelets are suspended in plasma. The stability of these biological colloids is essential for the proper functioning of living organisms. A deeper understanding of colloids and emulsions also helps explain the process of coagulation, where colloidal particles aggregate and settle down. Coagulation can be induced by adding electrolytes, changing the pH, or applying heat. This process is utilized in water treatment plants to remove suspended impurities from water and in the dairy industry to produce cheese and yogurt. Another interesting phenomenon observed in colloidal systems is electrophoresis, where colloidal particles move under the influence of an electric field. This property is used in techniques such as gel electrophoresis, which is widely used in molecular biology to separate DNA and proteins. That's all for today's session on emulsions and colloids. I hope this discussion has given you a clear understanding of these important concepts. Don't forget to stay tuned for more in-depth and high-yield chemistry content, only on AskPrep. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.